All right, my laundry's going and I feel like it's really loud and I hope it's not loud in the video. So we're gonna talk about compound interest. So remember with simple interest, our formula was interest equals principal times rate times time. And that only accounted for like each month. So on the original amount of the loan, the term of the loan, and that kind of stuff. Well, compound interest is going to pay it at regular intervals. So after each interval, the interest is added to the original principal, and like we keep going with it. So instead of having to do the simple interest over and over and over and over again, we're going to use a compound interest formula. So this is, because this is going, what it's going to do is going to account for the original principal and all the interest that's added in every period. So here's the formula. I'll lay out what the different variables are. So A is a final amount. P is that principal amount. The 1 plus always going to be there. R is still going to be that rate, but as the decimal. So an example, 5% we'd really use as R equals 0.05. And then N, that's our new variable here. It's going to stand for the number of times it's compounded. It could be yearly, it could be monthly, annually, bi-weekly. I'm trying to think of some other things. And then T is going to stand for time. So let's run through some examples with this. So principal is $5,000 with an annual interest rate of 3.8% compounded monthly for 5 years. So our final amount is we have our principal, 1 plus, and then our rate as a decimal, so 0.038 over the times compounded. And I guess I should put, it's usually in a year. So if it's monthly, then it's going to be 12. And then it's raised to the NT, so N being 12, 5 being T. And then we just plug this in a calculator. So if I'm doing it in my phone calculator, I do it inside out. So I go the 0.038 divided by 12 first. Then I add 1. Then I raise it to the exponent. And if that number is easy to do, I go ahead and do that. So 12 times 5 is 60. And then I get that number, and then I multiply it by 5,000. And I get a final answer of 6,044. And then since we're dealing with money, I'm going to round to 2 decimal places. So 43. All right, I'm going to do it again for this next one. Principal is $18,500. Annual interest rate of 6.25%. Compounded quarterly for 17 years. So find the final amount. 18,500 times 1 plus our rate as a decimal, so 0.0625 over n quarterly is 4, and then 17 years. So let's see what that final amount is. I'm going to do the 4 times 17 first so that I know what to use. All right, so 0.0625 divided by 4 plus 1 raised to the 68 times 18,500. So I get a final amount of 53,093, and we'll go 55 cents. Let's keep going. So we invest 7,500 into an account that earns 4.5% compounded quarterly, so again 4, and then the value after 10 years. So, all right, 0.045 divided by 4 plus 1 to the 40, and then times 7,500. If you do your parentheses correctly, in the calculator, you should be able to do it all at once. I've always found it's hard. That's why I do it all the way inside out. But you'd have to throw parentheses here and then around here. Then it should do it all at once. But I get 11,732 and 83 cents. Let's do another one here. So we have 10,000 at 5.6% compounded daily, and then for 20 years. So daily, here's what's kind of weird. There are 365 days in a year. We're not going to count leap year, so we're going to use 365. Now, fun fact here is banks would usually use 360 instead of 365. I don't know the history behind that, but I guess it's just another way for them to cheat us out of our money if we were to be trying to get money from them. That's a whole 5 days they're not giving us interest for. But on the opposite side, if for, I don't know if loans are calculated this way, but I would prefer if I'm borrowing money that, yeah, forget about those 5 days. But for the sake of this problem, daily means 365 days. And let's throw this in. 365, times 20 is 7,300. So I can type all that in. So 0.056 divided by 365. Then add 1. And then raise that to the 7,300. And multiply by 10,000. So I get 30,645 and 91 cents. Okay. Now we could go backwards and not have all the information here, because sometimes we want like maybe a savings goal. So maybe we want to know how much would I have to put in now so that in the end I get out a certain amount. You know, maybe I want to save up for a down payment on a house. So I know how much I want to put down in the end, but how much would I have to save now and put into this account? So, all right, our final amount is 250,000 invested at 6.5. That should be percent interest compounded monthly for 30 years. So instead of doing all the algebra and solving the original formula, I went ahead and did that for you. So the only difference is PV stands for either present value or it's that principal amount. You just typically see it in the finance part being PV instead. So, all right, let's plug our numbers in. So our present value, or what we would need to invest now to get out the 250,000 later, is the 250,000 divided by 1 plus the rate over compounded. Let's see, it's monthly, so 12. The NT. 12 times 30. All right. So now this becomes a calculator problem. If you want to, because this is a big denominator here, you can use Desmos as your calculator. Desmos.com/ oh, I can't fit it all right there. Calculator. I'm going to pull up the app, and then I'm going to plug this in. Okay. So it will pull up something like this. But we can use it anyway. So doing the division to make a fraction. So 250,000. And then over all this stuff, 1 plus, and then another fraction, 0.0675. Monthly, and then raised to the 12 times 30, and there gives me my amount, 330 or sorry, 33,186 and 23 cents. Okay, I'll go back into the notes. 33,186 and 23 cents. All right, 500,000 invested at 7.1% quarterly for 40 years. The present value is that 500,000 over 1 plus 0.071. Quarterly is 4. And then for 40 years. I'm going to go back and just change all those numbers. I'll just do a new line. 500,000 over 1 plus 0.071. See, it was quarterly, so 4. Then all of that raised to the 4 times 40. 29,949 and 68 cents. Okay. And the last one here. So Pilar plans early for retirement, believing she's going to need $1.5 million to live comfortably after the age of 67. How much will she need to deposit at the age of 23 in an account bearing 6.35% annual interest compounded monthly? Well, let's see. We want to know how much we want to put down. We want 1.5 million. We know the percent, 0.0635 for compounded monthly. We just need to know how many years will have passed. So if we're going to put in at age 23, and then we're going to retire and take it out at 67, what is that? 44 years. Right? I'm just going to go change all those numbers. Or I'll just do a new line. Oh, let me make sure I have all the zeros. 500. 1, 2, 3. There we go. And then over 1 plus 0.0635 monthly for 44 years. All right, 92,400 42 and then 50 cents. $92,000. Oh, I already forgot the number. 44250. 44250. Okay. And I think, yeah, that is all for compound interest. So if you have any questions, let me know.